Hello everyone, this is Asghar Nazir. In this video we will discuss about the typecasting. But before we can discuss about the typecasting, we need to revise few things related to the variables and their capacity. So let me create a new class and let me define the variables inside that class. So I have created some variables, and these variables, they also kind of tell about their capacity. For example, this byte, you can think of this byte as extra small box that we can use to hold the whole numbers. Then we have the small box, the short, that can hold slightly large numbers than the byte. Then we have the medium box, integer, that can hold the even larger number than the short. Then we have large box, then extra large, and then extra large. Now let me also put some comments so that it is easier for you to understand what is going on. So as you can see, we have the extra small, small, medium, large, extra large, and extra large boxes. These are the data types, and as you can see, we have 4 data types to store the whole numbers, and the reason why we have 4 because they differ in their capacity. Similarly, we have the 2 data types that can hold the floating point numbers, and the reason we have 2 because they differ in the capacity. So now what typecasting is, typecasting is basically the flexibility, the freedom of converting these data types from one to another. For example, Java gives us this flexibility that, hey, if you have a float box and it contains some kind of values, what you can do, you can store those values inside a smaller box if you want to. Otherwise, we don't need to do it explicitly. Now let's go back and let's discuss more about the typecasting. So what typecasting is, by definition, typecasting is when we assign data of one type to another type. So this is what typecasting is. We have some data stored in a variable. The type of that variable might be short, long, double, and we are trying to store that in another variable of a different type. For example, we might be trying to store integer inside a long. Now, why we need typecasting? So there are multiple reasons why one might need typecasting. The reason number one is, let's say we are doing some kind of calculations. Let's say we are converting the Fahrenheit to Celsius. Now, when we convert the Fahrenheit to Celsius, this is the formula. And if I put the Fahrenheit as 34, the results that I will be getting will be 1.1111. Now, these results, someone might not be interested in these decimal points. So what we can do, we can use typecasting to get rid of these extra decimal points in the value, and if we typecast it properly, we will get the value of 1. Another reason is we might be using the code that is written by someone else, and if they have used a different data type in their code, now we want to combine their code with our code, and believe me, it's a very common scenario when you will be working as a developer or as a tester. You want to combine the code written by other with your code, and if they have used a different data type, you might either need to change the data type of their complete code, or you can use typecasting and you can easily leave the code as it is and you can start using the results from their code. Another example might be, let's say you are doing something and accidentally you have used the wrong data type. Now you have done all the calculations, and now the results, they are produced in a different data type. Let's say, for example, in the integer, but you wanted the results in a long or in a double or in a floating point. So what you can do, instead of changing the data type of all of your code that you have written, maybe 100 lines of code, 200 lines of code, you can simply change the data type of the result, and you will be able to store the results in a different data type. Now there are two types of typecasting. One is called widening and the other one is called narrowing. When we are storing something from a smaller box, from a smaller container to a bigger container, then it is called widening, automatic, or implicit. The reason why it is called widening, automatic or implicit, first, why it is called widening, because we are picking something from a smaller box and we are putting it inside a bigger box. We are widening things. Why it is called automatic? Because we don't have to write any extra code when we do this type of typecasting. Why it is called implicit? Because it happens automatically, we don't need to do anything. The other type is called narrowing, shrinking, manual or explicit. In this type, we pick something from the bigger box and we try to store it inside the smaller box. Here we need to explicitly write code to make this happen, otherwise we will get an error. That's why it is called manual. That's why it is called explicit. Why it is called narrowing? Because we are picking something bigger from a bigger box and we are trying to fit inside a smaller box. That's why it is called narrowing. Now these are some of the examples. For example, we have an integer large box and we are trying to store that large box inside an extra large box. So it's widening, it's explicit, it's automatic, because we don't need to write anything extra. But if we are trying to store from an extra large box, let's say from a double to a float, float is a smaller data type, double is a larger data type. Here we need these extra pair of parentheses and we need to specify this float. That's why it's called manual. That's why it is called narrowing. That's why it is called explicit. Now let me show you the demo and the things will get more clear with the help of this demo. So for example, if I try to store from this extra small box, let's say for example I have this medium box and I am trying to store something from extra small box. So extra small box contained 123 and the small box contained 2345. We don't get any errors, we don't need anything extra, anything special. This happens automatically, and this is widening or automatic or implicit typecasting. Still we are converting from one data type to another one, but check this out, we don't need to do anything extra. This extra small box is contain the value 123. We have successfully assigned that value to a medium box and it worked perfectly fine and we get the results. But if we try to do the reverse, if we try to put a bigger box and if we try to store the results inside a smaller box, it will not work and we will get errors. So for example, let's say I pick this small box and I try to put something from the medium box in it. The moment we try to do that, check this out, this is small box, smaller box, and this one is the medium box. It contains a value which is bigger, which cannot be easily fit inside a short. So Java will give us an error, and if we still want to do it, the responsibility is on our shoulders. Java does not go and check what is stored inside this box. If you think that this conversion is not going to give you incorrect results, what you can do, you can go ahead and you can force Java by typing these parentheses and then specifying by saying that, hey Java, I know that this is a medium box, it's an integer, but I still want you to convert it to a shorter box by this. And this is how the syntax works. We write the data type, then we assign it to that data type. So because we are trying to assign it to a short, that's why we wrote short here, because this small box in which we are trying to store the value, it's a short. And now if we try to run this, if we say small box, and if we run this code, you will see we will get 120 again, because this value of the medium box, it was updated here, it was 123 when we try to store it. So this is how it works. Java does not care what value is stored. Java only checks, is this a bigger box, and is user trying to store something from a bigger box to a smaller box? That's all Java cares. Now let's say I store something cannot be fitted inside this smaller box. Let's say for example a bigger value, something like this. Now I should be getting this 222 as the answer, but when I try to run it, I will get a different wrong results. So it's up to us, the programmers who are trying to force Java to typecast. Yes, we can try to store things from a bigger box inside a smaller box, but it totally depends on us. if the value will not be able to fit inside the smaller box, we will be getting incorrect results. Okay, now let's do another example to understand why we need typecasting. So let's say, let me write down the formula to convert the Fahrenheit to Celsius. So this is the formula that we can use to convert the temperature from Fahrenheit to Celsius. So C is for Celsius, and then the formula is we put the value of the Fahrenheit. So let's say, for example, int Fahrenheit is equal to 34. So formula says 34 minus 32 multiplied by 5.0 divided by 9.0. Let's say we are trying to do some kind of these calculations and we are trying to get the results in a proper format that is easier to process or easier to understand for others. So if I run this code, I will be getting an answer something like this. Now, for some of the user, they might be comfortable with this answer, but most of the user, they might not be comfortable with this answer. So what we can do, we can use typecasting again here. What we can do, we can use the parentheses like this, and then we can use integer, which will try to convert this to an integer. And because integers, they cannot hold the decimal numbers, we will not be getting this decimal part and we will only be getting the whole number part. So as you can see here, again, with the help of typecasting, I was able to get rid of these decimal points from this number. So if you are doing some kind of calculations and if you want to get rid of the decimal points, you can typecast your double numbers or floating point numbers to integer. This is one of the examples. And let's say if you have used the code from someone else and if they have used a different data type, again, you can typecast to get the results in your desired format. That's why we use typecasting. And let me reiterate the things. What is typecasting? Typecasting is storing the contents from one type of box, one type of variable into another type of variable. There are two types of typecasting: widening, narrowing. When does the widening happens? When we store something from a smaller box inside a larger box. When does the narrowing happen? When we store something from a larger box inside a smaller box. We can do that, but whenever we are performing narrowing, depending upon the box in which we are trying to store the values, sometimes we might get proper results, other times we might not get proper results. It's the responsibility of the programmer to make sure that they are getting the proper results. So I hope this video was helpful. I will see you in the next video. Bye bye. Don't forget to subscribe and hit the bell icon.